Yeah, we are on live now.
Okay.
Hey guys, thanks for joining in. We'll just wait another 1 or 2 minutes before we start with the presentation. So until then, you can post or comment down below where are you from and where are you from? Where are you joining from? Yeah. So we have people joining from Germany. We have people joining in India, from India. And thanks guys for joining in. We'll just wait another 1 minute to start so that let everyone join first and then we'll move ahead with the presentation. Awesome. I think we have participants from a lot of countries, and okay, it's high time now. We can start. Thanks guys for joining in. I'm Kaushal Bhavsar. I am VP of Platform Engineering at Omdena. And today, me with Yudish here. Yudish, can you introduce yourself quickly as well?
Hi everyone, my name is Yudish. I'm a data scientist at Moneyline, but I'm also platform engineer at Omdena Law, where I sort of lead and maintain Omdena Law, which is a AI for Good library.
Thanks for the introduction, Yudish. In today's call, just give me a second. Awesome. In today's call, we'll be discussing about how to build test cases for machine learning projects. And the reason why we set up this event is because when you work with real world applications of machine learning, testing is a very vital skill, but often overlooked skill that is expected by employers and many companies, but generally are not taught in conventional ML courses or coursework that you do in your colleges or any other coursework. So we thought maybe why not create an event that can help collaborators or enthusiastic people around the world to build foundational knowledge of testing ML applications. And we have Omdena Law with us, and Omdena Law is going to act as an example for creating test cases of ML applications. We'll walk you through multiple test cases during the whole event, and we'll look at examples from NLP, computer vision, and many other domains. And we'll see how basic of testing works, especially on Omdena Law, and how you can implement in different domains. Next slide, please.
Yeah, Kaushal, could you start recording?
It's already started recording. Don't worry.
Okay.
So first of all, we'll look at why testing is important, and then we'll have a brief look into Omdena Law. As I mentioned, that Omdena Law is going to be the example case here. So we'll take a look at Omdena Law and how you guys can also be part of Omdena Law. We'll touch some testing basics as well, and then finally move on to some examples on Omdena Law. We know that this whole event is going to be technical, so you guys will have some questions and comments about the whole event. So we have a mid Q&A after testing examples with Omdena Law. Then finally, we'll move on to how machine learning testing is different from the software testing. And then we'll take another look at some examples for machine learning testing specifically. And then we'll finally move on to some additional checks and standardizations that you can apply during a deployment stage of or deployment, or at least a development stage of any ML applications. And then finally, we'll have good 10 minutes for another Q&A session. So why testing is important? As I have mentioned, that majority of the employers and companies around the world will definitely ask for testing, or may expect you to know something about testing, especially when they are working with development environment and when the product is already deployed. So testing your code is basically having like a rumble strip around the road that you around the road, and that will let you know when you are gliding off the road. They will let you know that you are gliding off the road and help you to understand or make a decision to go backtrack on the road itself. So this is how testing will help you. They will let you know when you are making a mistake, and alert you that, hey, there is something wrong with the code, and you can correct your mistake, and help. This will basically help you your code not to crash during deployment, or when a user is already using it. So it will not remove 100% of errors or 100% of bugs. So that's not a placebo for any code errors, but still it will make you confident enough. It will make you trust your code enough so that you can at least deploy your code. So in this particular whole event, we are going to take Omdena Lore as an example, and we are going to look at test cases that I deployed on Omdena Lore. So Omdena Lore is basically an open source data science package that we have created from scratch. And basically the whole reason behind creating Omdena Lore is to provide collaborators around the world a resource that they can use to accelerate or decrease the development time of the whole project cycle. So some of the features that we provide in Omdena Lore are free, comprehensive, ready-to-use Python classes. And also we have functions to solve any machine learning problems in an accelerated manner. So we have pipelines, we have codes, we have various utility functions, we have notebooks, so you can check out them, check out those codes, and you can basically learn a lot about a particular domain when you look at the code that is inside Omdena Lore. This is going to help. This is also going to act as a tool to help speed up the testing of machine learning codes as well. We are currently developing it, so once that's ready, it will really help a lot of collaborators to, or developers to, speed up the testing of machine learning code as well. And finally, the most important thing that I want to mention here is that Omdena Lore is a platform to meet industry innovators. And from an industry innovators perspective, they are able to meet enthusiastic collaborators from all around the world. So industry innovators like NGO startups, these guys post their problem statements inside the repository. Basically this helps collaborators to work on real world problem statements and real world issues. This gives them a lot of experience as well as exposure to that development environment. And when I talk about development environment, the testing generally comes in play as well. So if after this event, if you're looking to test your knowledge about testing itself, you can come up to the to Omdena Lore, visit Omdena Lore. On the right, you can check out the Omdena Lore landing page, or you can either visit omdena.com/omdenalore. You'll greeted with a page that can this will contain a lot of information about how you can collaborate, how to install Omdena Lore and use it in your project, and also how as a company you can become a partner of Omdena Lore. And also, if you want to apply to become a contributor, you can check out the left link and fill out a form. It does not take even like 2 minutes to fill up the form. And when you are done, once your application gets accepted, you can become a collaborator of Omdena Lore as well. So I'll pass on to Dhishnat now. He'll be walking you towards the rest of the event as well. And don't forget to post your questions down the comments below, and we'll happy to respond to you as soon as possible. Over to you, Dhish.
Thank you, Kaushal. So yes. Hi everyone. So the first part about testing machine learning code is like I'm going to take a step back and look at just general software testing. How can we do that? Just to get everyone on the same page, because it's not necessary that everyone understands how testing works. So here I'm going to introduce the concept of the 4-phase test pattern. So what the 4-phase test pattern basically does is it describes a clear way to structure your test. So it's based on this book called the X-Unit Test Patterns. It's quite an old book, but it goes into really detail about how you can perform unit testing. And also throughout this whole talk, I'll be mostly just talking about unit testing, not integration testing. Unit testing being just testing a single functionality of your code. And so how the four-phase test pattern describes it is that you start off with a setup. So you establish some preconditions to the test. These are things that you need to sort of create the test in the first place, like to whatever functional testing. These are the things you need before that, arguments, whatever. You need those to sort of get the output in order to test it. Then from there, you want to exercise. So you want to do something to that system. You want to take whatever you took to set up and use that and get the output that you want to check. And from there, you want to verify it. So you take the output from the exercise from that function and you check it against the expected output. So just going back, the setup also requires you to sort of pass in what is the expected output. So you know, if you have a function that's taking that's adding two numbers, it takes number one, number two, you add them together, and then when you're verifying, you sort of have this precondition that checks, okay, is it really adding them correctly? And you also have a cleanup, which sort of returns the system to the initial test state. Cleanups are somewhat not going to be used throughout this whole talk. Traditionally, what you would use for cleanups is maybe if you're doing backend roles where you need to test a database connection. So you would basically set up a database connection, like a fake one, or a real database connection, and plug in some fake data. And from there, you run your test. And at the end of that, you would sort of clean up by shutting down the database so it doesn't live. And so I'm just going to show a couple of examples on how you can run some tests. So in this example here, we have a function tokenize, takes in a list of strings. And what it does is it basically tokenizes them, or basically splits them into individual tokens. And then at the bottom, we have a test token function, which is our test. And it sort of follows the same 4 steps as previously. So we have the setup, where we have the input list and what is expected. And we have that exercise where we take that function and run it on the input list and gives us the result. And from there, we sort of verify it by just asserting that, hey, is the result the same as the expected? And we're not running any cleanup because it's not necessary. Another example that we have is sort of image normalization. So when you normalize an image, you divide it by 255, and this sort of aids in training your neural network on it. And so the whole setup sort of follows the same exact thing, where you have your input image, you can really create anything. You could even load in a real image, but here I'm just using a simple NumPy array. And you have the expected output, like according to how it should when you normalize. It's a bit difficult to sort of get these values, but normally we sort of calculate them beforehand. Moving on, from there we exercise it by running the input image with the same arguments that are necessary. And this time, instead of asserting, we sort of leverage NumPy's testing library. So they have a lot of functionality related to testing. But in this case, we're just asserting that, hey, are these two arrays the same? It's a bit more difficult to use the assert statement, so we use NumPy here. So let's talk about testing philosophy. So this is for unit testing, but ideally, a single test should only test one functionality only. It shouldn't test multiple things at the same time. So going back to the example, if you notice that I just tested one single thing, I didn't, this exact code could actually be part of a larger pipeline, but we're just testing this one thing at this one time. So why do we do that? So it's easy to sort of see where things go wrong. So when you run your test and check, you will know exactly where it fails. Secondly, tests should not depend on external data. So what do I mean like this? Let's say your function sort of relies on an external API that takes 1-2 minutes, maybe even longer, an hour. When you're running your tests, you don't want your test to sort of take an hour because of that data or that API call. So what you should do is sort of store that data beforehand in your repository and access it when you're actually testing the code. And I'll show you an example later on of how this can be done. It's called mocking. So you're just basically mimicking that API call, but not actually running it fully. And yeah, so tests should reflect what is actually used in production. So it's really dependent on what your system is doing. So if, for example, your function is only supposed to work on integers, then you should really only just test the integers. You don't have to test it on floats. And lastly, also, 100% test coverage, as Kausha mentioned, does not equal to no errors. Your test cases that you sort of write beforehand are sort of dependent. Like you could still make mistakes there. Like you could still exclude some certain scenarios or outliers. So it doesn't completely minimize it. And also achieving 100% test coverage is sort of nearly impossible because there's just some code that you really can't test and it's not necessary to test. So, okay, I'm gonna switch over to another screen, uh, which will be the actual coding part of this event. Okay, yeah. So, okay, can everyone see my screen?
Yeah, it's visible.
Okay.
You can go ahead.
Okay. So let me just walk you through Omdena. So this is the structure of Omdena. So we have the main repository, and we have all these different folders related to specific functionalities, like depending on topics. So we have computer vision, we have data sets, we have natural language processing, we have optical character recognition, we have satellite imagery, we even have time series. So these are all the main functionalities of the library. And for this event, I'm going to be testing out specifically right now the natural language processing functionality, which is actually just pre-processing some text. And I just wanted to show that the test sort of exists outside of the main package, so it's external. So if a user downloads the library, they shouldn't, well, download the test at the same time, because there are a lot of things that testing requires, such as this external data that I mentioned previously, which I'll talk about later. So the static data, we have a directory that just holds all the static data. So, okay, and let's look at the code that we'll actually be testing. So under natural language processing, we have this class called text preprocessor. It leverages Spacey for pre-processing a text. Spacey is a really good library for that functionality. And here's a simple example. So we take the class and we call this function load model. So load model just returns a Spacey model. And we pass that model back into the class and initialize the class, which returns a preprocessor. And this preprocessor has functionalities such as preprocess text. There's also another function called preprocess text list, if I'm not mistaken. It's down, yeah, this one. So the main difference is this first one just runs it on a single string, whereas the other one runs it on the list of strings. Very similar. So let's look just a bit more into how it works. So as you can see, there's this initial function called load model that returns the model. And what it does is that it actually relies on you beforehand, if you haven't downloaded the model, to run this function, downloads Spacey model. And it'll download the model, make a HTTP request and get it for you and download it locally within your virtual environment. But thinking about it, going back, I remember I mentioned that we shouldn't be making any sort of external data API call. So how are we going to do that? We're going to fix it with mocking. So let's just look at the code. So this is the file called test preprocess text. So it's just the same name as the file previously. This file is called preprocess text, and this one's called test preprocess text. So we have to follow this sort of format when we're testing. We'll be leveraging the library bytest. So bytest requires that all the functions that you test, but be it the functions or the code, functions or the file, have this prefix of test in front of them. So it's very important for that. And let's look at a very simple example of a test. So I have this function called test preprocessed string basic. So I know this might look scary a bit, these two things here. So this add and whatever word you have here is called a decorator. So it basically sort of sprinkles functionality onto whatever function you have. So you can really just take any function and add in whatever functionality you want. Here, these are both testing related functionality. So let me just walk you through how it works. So let's look at the function. So it first takes in two arguments, text and expected. So text and expected are basically what we need to sort of set up the model. We'll just sort of ignore this top part here, but we'll just focus right inside the library, as inside the function. So we load the model, we pre-process it, we pass the Spacey model, and we pre-process it, and then we pre-process the text, and we assert, is it correct? Okay, that's like the most basic way you can do a test. But so let's break it down here by what are these decorators doing. So let's start with the first one. So patch. So patch is actually by, one second. Yeah, so patch is by unit test mock. So it comes from that library. And what it does is it basically allows you to do this really cool thing where you can take whatever functionality or whatever function you have and sort of patch something else, use another function to replace it. And this gives us a lot of power when it comes to mocking. So first argument that you need to specify is, okay, what function are you going to patch? So we're actually going to patch this text preprocessor class that comes from here. Okay, and we're going to patch the load model because if you can remember, load model sort of returns that spacey model, but it's not necessary. But we don't need to actually make a HTTP request. What we can actually do is replace it with a new function. And what does this new function do? This new function up here is called load spacey. So it's like a helper method. And what it does is basically we take the data from static data just now here. So static data, we have Encore Web SM. So this is actually the spacey model that we are loading just now, but in its raw form. So we can directly load it. So we access it using a pathlet. Basically, this line up here is basically indexing upwards. So you're going like back from a deeply nested folder, you're going up until the root directory, and you're accessing static data. And you're also prefixing, postfixing Encore Web SM. So this is the model part, and then we're loading it using spacey, and we're just returning that. So we're returning the spacey model. So what we're really doing here is that we sort of swapped out, these two functionalities, and it's kind of cool. And it also enables us to sort of just replace it. See, in down here, I sort of call the function, but it doesn't require us to actually download the data we want because it's already there. It's calling that function, it's getting it for us. And that's sort of patch. Moving on, we have bytest mark parameterize. So bytest mark parameterize basically gives us the option to pass in a lot of test cases we want. So instead of creating like 10 different functions like this and just passing in, each case, what it allows us to do is just pass in a list of tuples. So here, initially you have to specify the first argument here. So this string matches what arguments you're going to pass in. Okay, and the first one next to the comma. So it's sort of split by comma. So you would take that, and this text here follows this tuple, the first value, and expected follows this value here. So this is the input text, okay, and this is the expected output. So just one second. Okay, so now if we run that, so in the root directory, we can just run bytest. And if you have it installed, it will sort of give you, it will sort of run the test for you. And lo and behold, we have passed test. Now that's just some external warning, but not relevant. So going back, now, okay, this works great. Okay, this is super basic, but we don't have like, just one single test. Tests actually depend on a lot more than just your inputs and your outputs. So let's look at the proper version of this. So proper version of this, we'll ignore the decorators for a second and just go into the directly what are the arguments they need. So we have text and expected, but we have additional things. So we have arguments and exception. So let's go back to the model. So we allow you to sort of in the init method, we give you like this different Boolean values that you can choose. So if you want to remove numbers, remove special characters, if you want to remove stop words, if you want specific part of speech tag removal, or you want tokenize, you can use them. So how we're going to test this is that we are going to sort of test each argument independently. So we're just changing each other argument on their own, and we can sort of pass it into the model. So we'll pass it in through the decorator above, but if there is the argument, we'll pass it in directly using this double asterisk. So this basically like unpacks key value pairs into the class. And if you're not using it, then we don't need to pass it. So that's why I have this else statement. Moving on, finally we have the exception case. So another thing is that test cases aren't just input, outputs, arguments, and all this. They're also there are cases where you have your code is supposed to fail, supposed to throw an exception. If it doesn't, then there's something wrong. So if there is an exception, we run this context manager called bytest raises. So basically, bytest raises checks whether, okay, is the exception passed? Does it, really raise at this moment when we run this text? Okay. Other than that, the code is still the same. So I'll just walk you through all the different scenarios that we have. So, okay. So in the most basic test you can do is if there's no input, what is the input, or what's the expected output? So we should have an exception. This follows the same format as up above here. Sorry if it gets a bit confusing. And also we test default arguments. So we don't change anything. We don't pass in any extra arguments. It's still the same as the first example, but there's no exception and there's no arguments passed in. But let's say we want to set remove numbers to false. So we pass in this dictionary of the values that we want to update. We're just passing in remove numbers to false. And it shouldn't raise any errors. And we repeat this for basically every single argument. I know it might seem a bit troublesome, but this is sort of necessary when writing tests. And I hope it, and also you sort of need to think about this beforehand when you're writing your code. So you have all these different scenarios that you're testing and all the different outputs. So we have tokenize equals true, lemmatized equals false. Here we have a specific part of speech text to remove. So for this string, we're actually specifying, okay, for this input string, let's remove the verbs. So verbs are like buying, selling, looking, like actions you can take. So we want to remove them. So expectedly, when we preprocess it, it should look like that. And yeah, so let's go back and run this now. Sorry, don't think I saved it. Yeah, so it will run a green dot at the bottom for each single sort of different scenario that we have. You can see that we have, I think, 8 here. So we have 8 different test cases for that particular function. And so that's sort of an overview of how you do testing, just from Omdena Law's perspective on this one case. So going back, I think we can have a sort of Q&A on, yeah, let me just go through the Q&A.
Yeah, just can you open the presentation again?
Okay, yeah, sorry.
Quickly open the slide itself. Okay. Awesome. So the people who have joined, there is a burning question that will you be able to provide the code and the presentation later on. So the whole event is actually live on YouTube as well as on LinkedIn. So if you find our page Omdena inside in YouTube or LinkedIn, you will be able to see the whole live event saved there. So you can watch the whole event again. If you're talking about a code itself, if you want to check out the code that is inside that Yudish just explained upon, so what you can do is to have to apply to become a collaborator of Omdena Law. Since this whole repository is there, you will be able to not only see the code that Yudish is mentioning, but also other test codes as well as other domain test examples as well. So if you're interested in computer vision, you might not completely get the NLP, but you can check out the test codes for computer vision and you'll have an idea about that. So if you want to apply to become a part of Omdena Law, you can just quickly go on to omdena.com/omdenalaw, and you will see a contribute button there. Just click on it, fill up the form, and we'll take care of the rest. Another question is that, first of all, before going to question, just quickly pointing out that we have a challenge coming up on 6th of November. We, as a partner, we have Giga Team with us, Giga Team on the November 6th challenge with us. It's an initiative by UNICEF and ITU. And since this whole project is going to be based upon Omdena Law, we'll have examples on testing the code as well, and you will get a hands-on experience on developing test cases for live or deployable code. So it's a good opportunity for you guys who are interested in creating test cases or either working on an ML project. you can just go ahead and quickly apply to this project, and we'll be happy to host you inside the project. So you can scan the code here, or either you can visit the project page itself, omdena.com/project/omdena-lore-x-giga, and you will be gone through that. You can go through that whole project as well. What is the project required and everything else, and you will also have an access to the code as well. Can a person with somebody asked, can a person with no experience in AI and ML join the challenge to gain experience? Yes, if you want to join this challenge, you can still apply to become part of this challenge. Even if you don't collaborate, you can still observe the whole challenge going on, and you can, wherever you feel like collaborating, we have documentation, we have different tasks that you can still take part in. So you can contribute in that as well. Somebody asked, after the presentation is over, will it be able on-demand viewing? Yes, it will be available on YouTube and LinkedIn, as I mentioned. Somebody asked, Ryan asked, what is your opinion on testing that functions are called? Would you like to answer that, Yudish?
Okay, yeah. So actually, I'm still a bit confused about the question. What is your opinion on testing that functions are called? Ryan, could you could you just ask the question
Can
again,
you
like in
please
a different
elaborate?
format?
Yeah,
Yeah,
because
yeah.
I was too confused about the whole question. But can you elaborate and post it again, and I'll answer that. Where is the live event? Can we find the YouTube link? Okay, what I'll do is I'll post the YouTube link on the LinkedIn comment section as well as on the chat, so you guys can check out that video as well. I'll do that once Yudish starts speaking again. Can you kindly tell Yudish that this is awesome and really appreciated? So thanks, Yudish, for explaining everything. Somebody asked on LinkedIn that in the general case, we do not have the expected output. How can we get reference output?
We do not have the expected output. How can we get reference output?
Basically, he's asking that he does not know what the expected output is, or maybe he knows that, but he does not have that. So how to generate that expected output?
So it all depends. Like as you saw previously, I shared the testing example. So let me take a step back. How do you get the expected if you don't have it? So okay, this is something that you would have to really get started beforehand. So you got to know your expected output. That's a requirement. So you can't really test if you don't know what you're supposed to be expected. Like if, for example, your outputs are non-deterministic in a way, then it's a bit difficult. Like it's sort of testing code that you don't know the output might. I can't see a way to do it, to be honest. Yeah.
Yeah, and to generate the expected output, what you can do is generate it manually, because to be very honest, if you are working on one single expected output, it's not going to take a lot of time. Let's say if you are working on a project that can detect if there is a blank image or not, you can just create a blank image manually and put that as the output of that expected test case and work on that. Or either on the NLP side, if you're working on removing something on a big text, you can shrink down the text and create the expected output manually. I think that is the way to go. What is @static method decorator here? Can you please repeat? So Yudish have mentioned the static method very well. So what I would suggest you to do, Alok, is to go to the YouTube channel and please view the section again. I think it will help you to understand the whole static method. And in any case, Yudish, would you like to elaborate on something like there?
Yeah. So could you explain the question about the static, the decorator? Is it?
Yeah, so he's just asking like what exactly is the static method and what's the decorator?
Oh, okay. So let me 1 second. So so static methods, this basically so we have this class text preprocessor, and we have a static method download spacing model. So we don't need to instantiate the class. Like basically, you don't need to call let's go back to the example. So we don't need to call don't need to instantiate the class with whatever initial arguments it needs. So we can just directly call it. It's not like a helper methods per se. You don't store anything. What you normally do static methods are for sort of functionality that's related to what you're doing, but not tied into the initial arguments of the class. So compared to this second line here, where we have text preprocessor and we pass in the spacing order. So this is instantiating the class, whereas this is just calling the static method of it. Hope that answers it.
Yeah, I think it does. Thanks for answering that. So Jasmine asks where we can find the code. So as I have mentioned that if you want to access the code that Yudish is just explaining about, what you can do is just quickly go to the Omdena Law page, omdenalaw.com/omdenalaw. Click on the contribute button, fill up the form, and you will get access to the whole repository. Not only will you will get access to what Yudish is mentioning, you will also get different examples of testing code. You'll also get access to different domain testing codes as well. So it will be really beneficial if you can just directly go and apply for becoming a part of Omdena Law. You'll get the complete access to the whole repository. So Ryan, Ryan, sorry, I cannot hear the name of the website of the codes. Will you able to type? So what I'll do is I'll post the link of the contribute button as well as the Omdena Law page down in the chat, so you can check out from there. So Ryan just elaborated his question. At my company, sorry.
Yeah, okay, so I can read it. Yeah, at my company, some of the test codes are asserting that functions are being called with the correct parameters rather than the return. But yes, you can definitely do that as well. Depends on what you're testing. That's also definitely perfectly acceptable. So yeah,
so you can directly assert in the function itself. You can just call the whole parameters and just check if the parameters are integers or floats or whatever you expect it to be.
Okay, yeah. I hope that answers it. And also just going a bit quickly, I forgot to show the coverage. So there's a library called coverage, and when you run it, I'm running using this command here. So it sort of gives you all the different scenarios that you tested in a nice format, and it shows the percentage of it like throughout all of them. And it also gives you like a percentage of how much code you're hitting, like how much are you testing. Like for this particular branch of code, I'm actually only hitting like 3% of the test cases, but it's just one functionality. So I just wanted to show that. And also, I saw that Jasmine was asking about whether there's code that's sort of external. Actually, for the next part, the second part, I have a Jupyter notebook that I use because I trained the model. So I can definitely share the link, but I'll mention it to Kaushal in a bit.
Awesome. So we'll just move ahead with the presentation because we have limited time with us. But I do see some more questions. I see your question, George. But like we'll move on with the questions in the end of the we have another Q&A session, so we'll answer those questions in the later stages.
Okay.
So, yeah.
Okay. So Kaushal's my screen. Okay.
Yeah, it's visible. You can move it. Yeah.
Okay. Yeah. So that was software testing. So what about ML testing, and how do they both just compare? So software testing, you have your data and you have your logic, and you have this sort of desired behavior at the end that you expect. And these tests ensure that the logic with that data produces a desired behavior. It's called white box testing. Whereas with ML models and machine learning, it's a bit different because you have data, you have desired behavior, but the machine learning sort of model sort of learns the logic to get that combination. So it's sort of flipped. And this is why it might not be necessary that you can actually test machine learning code the same way as software testing, but I'm going to show a couple ways on how you can do it. So machine learning testing, we have really two types of tests that you can run in parallel. So they're called model evaluation and model testing. Model evaluation covers, basic model metrics, like AUC, F1 score of your model, things like that. But like how you would normally evaluate a model, it's quite kind of basic. But there's also model testing, which I don't see people doing very often, and I don't blame them because there isn't anything open right now. It's still an area of research, and where you test explicit behaviors that the model should follow. And within model testing, there are three types of model tests you can do. So there's pre-trained tests. These are tests that you can prevent bugs early on during training. For example, making sure that you overfit a single batch of data, like a model overfits a single batch of data. So if you're training a really big model that takes a couple of days of training, you want to make sure that you run some tests to ensure that it's not going to throw some, NaN error in the middle of training, like after a few days, then you have to restart everything. After pre-training, we have post-training tests. So these are the predefined model behaviors that I was talking about just now, and I'll go into more detail in a bit. And we also have production tests. So this is something really important, where you monitor your models in production for specific characteristics, like is the model drifting from us? Is the model drifting when it's predicting? Is the model's AUC score sort of not adhering to a minimum score? We have to test this in production. For the purposes of this talk, I'm just talking about the next two after this. So pre-training tests, we have certain examples. You can assert that the output shapes of your model should be the same as the output shape of the labels. So if you have a multi-class classification with 10 classes, the output head should be the same as the shape of the labels. And if you ever gone on Stack Overflow, you can really see how many people just struggle with output shapes, input shapes to a model. So that's why it's really important to have assert statements around this, so you can at least check beforehand. Other than that, you should assert whether the range of outputs are within expectations. So if you have a binary classification test and those outputs are supposed to be about probability, so they both should sum up to 1. If they don't, then there's obviously something really wrong. So these are important checks that you could do. Then also you can check for data leakage. So data leakage is something really important, I find. It's very easy to sort of happen for anyone. So data leakage is basically where you have your data for your training set and your test set, where the training sort of leaks over to your test set, and when it's not, the model sort of memorizes at both of them, and you'll come to situations like, for example, if you're doing like a fraud model where you'll get like 0.99 AUC and be like, what's going on? But that's a clear indication of data leakage. So we have to make sure that we have tests in place to prevent that. And another example that I'm going to show is that you got to make sure that your model overfits a single batch. So because the logic here is that if you can't overfit a single batch of data, then your model really can't fit to that data well. And next we have post-training tests. So this is like the really interesting part that I found. And it's still area of research, but I'm going to try my best to do this topic justice with the examples later. So we have, first one is called invariance tests. So these are sort of perturbations to the inputs that should not impact the output. So basically what it means, like if I change the input slightly or in some way, the output predictions shouldn't change at all. On the inverse, we have directional expectation tests. So these are the opposites. So slight perturbations to the inputs that should actually impact the model's predictions. So if I change the input slightly, definitely, or in some way, they should definitely make some predictions changes. And lastly, model performance. So we have your basic model metrics, AUC score. Maybe you are comparing a baseline model against a retrained model. So you want to make sure that the retrained model actually does do better than the baseline model before pushing into production. So you would have to have that. And also a really important part is checking the inference times of your models. A lot of people seem to overlook this, but inference times of your model sort of are really important, depending on the business use case. Because if your model is meant to be, serving hundreds of requests every second, and you have a model taking 1 second to give a prediction, it's going to give a really bad user experience. So we got to check for this. So going back to these behaviors that a model should sort of understand. So we have another way you can say is like this model should have some certain skills. And the skills really define a model as being better or good or being able to do the task at hand. So we have for NLP situations, you would have a different vocabulary and different parts of speech that the model should be able to recognize. You should have some robustness to noise. If there's a lot of noise, especially if you're dealing with chatbots, it should be able to handle them. Identifying named entities, so things like whether a person is the name is a person and things like that, as well as temporal relationships. So how does the relationship between words used in the front or later on in the sentence relate to each other, and also how like just removing certain words or replacing them impacts the model. For computer vision, there's some things that a model should also learn, and that it should learn that object rotation. Basically, if the image is rotated, the model should give the same predictions. Partial occlusion. So occlusion is when two objects sort of like pass by each other and one sort of stands in front of the other one, and it sort of blocks the one behind it. So your model should be able to handle things like this. Perspective change shift. So if you're making predictions from a different angle, will your model be making somewhat of the same prediction? How does your model handle lighting conditions? Dark, light. These are all important. Whether if it's raining, snowing, fog, maybe your model is deployed into a snowy area or an area that has a lot of rain. It should be able to handle this, as well as camera artifacts, so motion blur, things like that. Okay, so right now we're going to go into the testing of the example. So what I have here, 1 second. So let me just show it. Okay. So, okay, here I am going to show you, sorry, 1 second. Okay, yes, I think everyone gets my screen. So here I'm actually going to go a bit different, and we're just going to sort of train a model. And I mean, it's already trained, but I'm just going to show you through the code. And this model is trained on the MNIST dataset. So we're going to check how we can sort of test this dataset in real. So let's start. So initially, we're just loading in the dataset here. I'm using PyTorch, by the way. And in the dataset, we have this handwritten characters. So this is supposed to be 5. The title here shows is 5. And the data is just full of handwritten characters. So you're basically trying to predict, given an image, what is the class that this image corresponds to? Like, what number is it actually? It's sort of like the most basic example for machine learning you can do. And yeah, I just created a very simple CNN model just for time constraint, and I didn't want something that would take forever to train. And this is the structure of the CNN. So I'm using categorical cross entropy loss, and I'm using Adam as the optimizer. And okay, so let's talk about the first test that I think is very important. So overfitting a single batch of data. So a batch of data, what does that mean? So let's go back up 1 second here. So the data exists in this size of 60,000 by 28 by 28. That means there's 60,000 images. Each image is 28 by 28. And what a batch is, you basically take, instead of loading 60,000 and training at the same time, you sort of split it into chunks. This enables you to sort of handle larger data sets. If you didn't do this, and you might have this error where it says out of memory error. So that's why it's normal to use batch. So let's overfit for a single batch. So in PyTorch, you can use data loader, so you can sort of take the train data and specify. And I'm setting the batch size to whatever argument you pass in. You can specify whatever size. So the batch size can be anything, but we just want 1. So you're basically just training on that 1 sample. So it's 32, a batch size of 32. You're training for 32, and the model should overfit on that. Here I'm calling next iter loader. So basically what it does is it turns the loader into a generator and sort of just spits out one example, like one batch of data, because that's all we need. And the MNIST dataset gives us a tuple of images and labels. So what we need is the images, and the labels are basically what is that actual class, like is this image class 5? And we sort of train it, and we look at the results. So I'm training for like 100 epochs just for fun. But as you can see, the loss function sort of the loss sort of goes to nearly 0, which is a good sign. That means that the model is like very confident in the predictions, and it's sort of overfitting that particular batch of data. Another option that you could sort of do for this case would be to train and evaluate on the same dataset. That's another way you can do it as well. Totally up to you. In that case, you would just you would have another step where you evaluate on the same dataset. Okay, and the next test that I have is checking for data leakage. So data leakage is really important. It's more important maybe for time series, that's more prevalent, but for images, it's still a good thing to check. So what I'm doing is that I'm taking our train and test data, I'm just concatenating them together, like just putting them all together, and then I'm just checking, is the data set of is the number of elements as the concatenated data set the same as combining the number of elements for the train and test. So if they're both equal, it means that they both have the same number of elements and they're not like duplicates. So if they weren't the same, if the data set was like less, like this combination was less, it would mean that there's some of the data leaked into either the train or test. And once we go through that, we can sort of start training. So very basic training, model does quite well. It's very simple data set, and we reach a loss here, and we evaluate it. So perfect results, but I wouldn't use accuracy for proper evaluation on a multi-class classification. There are other metrics, but for these purposes, I'm just using accuracy. So, and now this is my favorite part, sort of the post-training test. So in variance tests. So how do we change the image to make sure that it does not impact the prediction? So one common scenario in computer vision is that if you rotate the image, it should give you the same prediction, right? And why do I say this is important? If you ever have used OpenCV, so OpenCV is like a computer vision library. It has this, gives you a lot of functionality related to OpenCV, computer vision, and I use it a lot and a lot of people have used it. And OpenCV has this face detection module called HA cascades. It's an algorithm for detecting faces based on images. And one thing you'll notice is that if you use HA cascades and you compare it to something like a better model, which is OpenCV has another one called DNN, Deep Neural Networks, the module for predicting faces. The main difference between these two models is that the HA cascades does not work well when you rotate the image. So if you have a face that's like rotated 90 degrees, it won't detect it at all, which is actually really bad. So what I did was I sort of mimicked that. So I here in this function, I just randomly get a data set, a particular image in the entire data set. And from there, I basically make a prediction on it. And before making the prediction, I rotate it 90 degrees and predict it. And so this is the output. So the image is actually 7. If you look at it, it's rotated anti-clockwise, so 90 degrees, so to your left. And it's 7, but the model predicts it as 0. So this is bad. Models shouldn't be doing that. But the good thing is that what can we do? Well, beforehand, we should be augmenting our images, basically taking images and rotating them, putting them in different lighting conditions and things like that. PyTorch has great functionality for that, build it. And your model wouldn't fail in this type of cases. So next up, we have directional expectation tests. So directional expectation test, it's just the opposite of what we did just now. So these inputs, like these changes to the inputs should definitely make an impact. And for this example, I'm going to use a Gaussian blur. So we're just going to basically blur the image. And by right, if you blur an image really badly, the model should predict really bad, shouldn't give a proper prediction. And so I'm using this function Gaussian blur. I think it's from SciPy. And the argument sigma sort of, the higher the level of sigma, the value, the more blurred it is. So 2 is pretty high. You could go higher. If you go like to 5, it'll actually just look like a round blob and you can't see anything. But I just chose 2 because it looks somewhat decent. So this number does not look like a 1. It looks more like a 6 from my looking. But it's okay. If the model fails here, that's fine. That's sort of expected. And lastly, the last test that I'm going to show is model performance test. So this is just a very basic one. You're basically predicting, checking the inference times of the model. So I have this function here that basically makes a prediction on a random sample of data, and I'm timing that function. And testing the latency, I'm just basically running that function about 1,000 times. And I'm looking at the median value, so the middle value of the sorted array of all different times. And from there, I'm checking, okay, is the prediction time less than 0.01 seconds? This is somewhat important, but it's not, how do I say this, super representative of what's seen in production, because production setting and your local environment aren't the same, but it's sort of a good way to sort of start off initially. And another thing is that when you work in data science, inference times are sort of important. If you have a model that requires very low, very high throughput, like you need a lot of requests per second, you wouldn't want to use like a super deep neural network like BERT, which needs a GPU just to get predictions like under 1 second or under half a second. So instead, you might opt for something more simpler, like a random forest. You can use LightGBM, XGBoost. These are all pretty fast, but give you really good performance. And yeah, I think that's it for the code. I think we can go to the Q&A. Just
awesome.
Yeah, also there's another part. Okay, Kaushan, go ahead.
Yeah, please.
Okay, so lastly, there are additional checks and standardizations that you can use. One thing we use at Omdena Law is pre-commit hooks. So these are basically functions of code that you can run when you make a commit. So you can basically go and get any sort of functionality that you want. For example, if you want to apply black is like for formatting your code. Like if you want to make sure that the code is formatted to a certain standard, black is a pretty good default. And we run this every time we make a put commit to the repository. So this sort of standardizes our code. So I don't have to go and check, okay, this person didn't use this formatter. This person isn't using, this person accidentally uploaded a huge file to the repository, things like that. So it sort of enforces styling. It's somewhat of a easier way to incorporate like CI/CD into your code, because you just need a YAML file and it's set up on the spot. And finally, useful resources. So I refer to these three things. So these resources, I would really highly recommend everyone sort of go and check them out. So effective testing for machine learning systems by Jeremy Jordan. So I learned about another paper, but from this blog, I sort of got that behavioral aspect of the whole testing. And next one is How to Test Machine Learning Code and Systems by Eugene Yan. I like his blog. His blogs are super detailed, and I recommend anyone to read them. And he also sort of built on, in addition to what that first article talked about. And finally, we have Beyond Accuracy behavioral testing of NLP models with checklists. So this is like, for model testing, I would say this is like somewhat of a bird type of paper. Like, it's that influential because it's very eye-opening paper that I recommend everyone read. And it sort of talks about different scenarios of how you can do that behavioral testing, but only for NLP. And they even have a special library called Checklist that does it for you, that you can use with visualizations. And I would, again, highly recommend everyone read it. And fine, Q&A. Okay.
Awesome. Thanks for that detailed explanation, Yudish. Before we move on to Q&A, just to repeat for anyone who has joined recently, we have a challenge starting at November 6th, and it's going to include all the testing. It's going to include a computer vision, and also you can also practice your testing. Whatever you have learned today, you can also practice it there as well. So we have a limited spots available. Just quickly go and check out the project itself and apply to that project. We'll start on the 6th of November. To start with the questions, we have one question from George. He asks, how do you test classification ML systems with supervised learning? Example, cluster models.
Clustering models. Okay. Personally, I can't answer the question, but because I've not actually read anything about it. My only experience has been about classification. That's also, I unfortunately can't answer the question, George. That's probably an area actually of research. So off the top of my head, I can't really think of anything.
Okay. So we have another questions. Are there prefixed sets of rules or templates for test cases that you follow while building test cases? Or is it just generated output versus expected test cases?
Okay. So this entire talk has been exclusively for unit tests. So that this structure follows unit tests. To build on it another level, it will be integration tests where you have different combinations of these unit tests that you test together to see whether they work. So yes, in that case, that would be it. But you would have to follow that. If you want proper templating, I would say you have to go back to the book I mentioned earlier. But this is about just unit testing. On the top of my head, I can't remember. There's another book that I would recommend for testing overall. So yeah, I would actually say prefer reading books on it. Yeah.
Awesome. Somebody asked, the contribution form requires to sign up to DAXUP. So Omdena Law is actually hosted on DAXUP. It's a version control tool just like GitHub, but with have additional functionalities for specifically for data science workflow. So you can just quickly go ahead and sign it up. It does not take a lot of time. So yeah, you have to sign it up if you want to be a collaborator in Omdena Law. Ryan asked a question, any tips for writing edge cases for invariance tests and directional expectation tests? We can write every single possible. We cannot write every single possible.
Yeah. So okay. Good question, Ryan. So I forgot to mention this, but these sort of post-training tests are highly dependent on your understanding of the data at hand. So you have to have some sort of domain knowledge to really think about these edge cases to handle. And unfortunately, I can't give tips on it. You just have to be experienced with the data. Say if you're working on a fraud model, you understand the data, you understand how how fraud works for that particular model with all the features. So you would really require that domain testing. But you also, in addition to that, you could also, if you have a feedback system in place in whatever model you have, from there you can sort of see where your model's failing, and you can sort of figure out how to handle it from there.
Okay. So somebody asked, how would you structure model testing? How would you run it as a CI/CD pipeline?
How would I structure it as a CI/CD pipeline? So okay, actually, yeah, in right now for Omdena Law, we don't have a CI/CD pipeline, but we expect in the future to sort of have this structure where we run tests in our CI/CD pipeline. So we're thinking about using Jenkins to orchestrate it. So basically, whenever a person say pushes to a particular branch that only Kaushal and I have access to, or they're making a PR, these tests are run right when they're making that commit. So it'll be used using that CI/CD tool that we're using. And that's how I would do it.
Awesome. Is fuzzy testing like hypothesis library used in machine learning?
Fuzzy testing like hypothesis library. Okay, I have no experience in fuzzy testing with a hypothesis library, so I can't comment, unfortunately.
Somebody asked, could we get the link to the Jupyter notebook too? All the notebooks all the code, all the notebooks that you have seen Yutish explaining, it's all available inside Omdena Lore. So just quickly go ahead and apply to become a collaborator of Omdena Lore, and you will get access to all the codes that Yutish has explained. So we have another question on LinkedIn. So it's basic. The question is on the model that you showed. I think the MNIST model. So somebody asked, is that model a mixture of convolutional 1D and convolutional 2D model? If yes, I would like to know if you can mix them, and how do we prepare images for convolutional 1D neural network?
Convolutional 1D. So convolution, yeah, you mean mix convolutional 1D and convolutional 2D, correct?
I'm posting the question on the chat so you can check it out as well.
Is that model mixture? So okay, so convolutional 2D layers basically takes in 4-dimension tensor. So you have 4D. So compared to a one-dimensional tensor, one-dimensional convolution, you would have 3 dimensions there compared to 4. So these 2D convolutions happen over the first two axes. So if you want to mix them together, what you could do is that, let's say if you have the input that comes in as 3 dimension, then you pass that to that one-dimensional convolution. And then before passing it to the 2D convolution, you would have to sort of expand the dimensions. And you should be able to do that, yeah. And how do we prepare images for convolutional 1D neural network? So preparing the images is, you could do a lot of things. It's somewhat similar to any computer vision neural network style thing that you do. You would just have to pre-process the image, normalize it, you would augment it. So it's somewhat similar. It doesn't really change specifically for convolutional 1D neural network.
Awesome. So we don't have any new questions coming up, and I think we are right on the time. So where do we, somebody asked, where do we apply as a collaborator? So all you need to do is to go to omdena.com/omdenalore. And Yudish, can you quickly open that as well?
This link here.
Oh,
right?
no, I mean the page, Omdena Lore page. So omdena.com/omdenalore.
Okay.
On the browser.
Okay, just 1 second. Yeah.
Yeah, so on the sorry, on the page, you will see that contribute button on the top. and also the install button. So if you click on the contribute button, you will this will lead you to a form. You can quickly go ahead and fill up the form. It does not take a lot of time. It will do ask you to sign up to Daxa, which should also not take a lot of time. You can directly sign up through GitHub or Google account. Since the whole repository is hosted on GitHub, which is on a version control tool, you'll have to sign up there as well. So once you sign up, we'll accept your application as soon as possible. And once we accept your application, you will have all the access to the repository. You can check out the code. You can check out the notebook that Yudish has just mentioned. And you can also check out the domain specific codes inside the repository. And you can see the whole structure and how the code works on top of all the whole structure. And even you can run the test that Yudish has shown in your own local machine. And I think that's it. And somebody asked, like again, somebody asked that where we can we see the slides that we have shared. So you can just quickly go ahead and check out the YouTube link. I have posted the YouTube link down in the comment section of LinkedIn as well as on the chat. So you can check out that YouTube video. It's live right now, but as soon as we are done, it will be saved as a video. You can check out the whole talk and read about it. So I think we are over the time limit, and there are no questions, I believe, or is it? Let me check. So okay, so we have no more questions. So this particular library is open source to use, but to become a part of the library, you'll have to go through an application process. It's not a selection process, it's just an application so that we have all the information so that we can, since the whole repository is actually maintained by some people, we want to have a proper communication between all the collaborators, and we give them proper access. We have continuous news updates for them. So once you fill up the form, once we'll accept you, and you'll have the access to the repository itself. And that's pretty much it. So thank you guys for joining in. It's been a real pleasure, and special thanks to Yudish for sharing so much information with us. And I hope to see you in the repository as well as on the challenge that's coming up. And see you guys. Thanks.